Oh, he's outside. Good morning, everyone.
Good morning.
How's everybody doing today?
Good.
Good.
Any questions? All right, so, oh, sorry. On Moodle, I put your groups. Okay. I think I got what you wanted. Anyway, that spreadsheet is up on Moodle, so please have a look at it. Yeah. If you're not with the group that you meant to be with or wanted to be with, let me know. Yeah. So the next thing we need to know is what your group is going to discuss. So today is October 8th. So why don't by the 15th of October, you guys let me know what your project is going to be within your group a week from today. Okay? It's cool stuff, right? All right. So when we were last meeting, we left off we were talking about the project, the problems for chapter 3. We have a couple of them left to do. And then we have more computer problems to do. So let's talk about this in a group. 5, in a study relating college grade point average to time spent in various activities, you distribute a survey to several students. The students are asked how many hours they spend each week in 4 activities: studying, sleeping, working, and leisure. Any activity is put into one of the 4, so that for each student, the sum of hours in the 4 activities is 1/6. Excuse me, sorry guys. Sorry. For each student, the sum of the 4 activities must be 168. So we have a model. GPA is equal to beta sub 0 plus beta sub 1 on study, beta sub 2 on sleep, beta sub 3 on work, and beta sub 4 on leisure plus some error. Does it make sense to hold sleep, work, and leisure fixed while changing study?
No, I don't think so.
How come, Connor?
Because you only have so many hours in a day.
Yeah, okay. Can you elaborate?
So if you already spend an hour swimming a day, you have to go to work for 3 hours a day, you sleep for 8 hours a day. You can't, whatever that adds up to, there's only 24 hours in a day, so you can't study for more than you already are. I mean, you can do less, and then you got more time for other things, I guess. So you really can't, if you're holding everything else constantly, you can't just change one thing. I don't think so.
No, you're absolutely correct. They told us in the problem that the sum of the four activities must be 168. So in 1 week, there are 168 hours. So you're exactly right. I mean, you saying in a day, there's only so many things you can do. Well, the problem expressly states that in a week, there's only so many hours that you can do that. So if you change study, something else must change, right? So you're exactly right. Why does this model violate multiple linear regression assumption number 3? Anybody even know what multiple linear regression model number 3, assumption number 3 is?
Wasn't it about collinearity between like two independent variables?
Yeah, no perfect collinearity. In the sample, I'm going to read it. In the sample, and therefore in the population, none of the independent variables is constant. Therefore, there are no exact linear relationships among the independent variables. So if you took study, sleep, work, and leisure and subtracted them from 168, in other words, if you had 168 minus sleep, work, and leisure, it would equal study time. That's a perfect linear relationship. Yeah, because as Connor said, there's no other things to do in the week. There's no other hours. How could you reformulate the model so its parameters have a useful interpretation and satisfies assumption multiple linear regression 3?
Could you drop one of the variables from the model?
Yeah, just drop one of the variables. That would eliminate that perfect linear relationship. Yeah? Very good. Okay, thank you, everyone. Let's look at the next one. Which of the following can cause ordinary least squares estimators to be biased? Heteroscedasticity, omitting an important variable, a sample correlation coefficient of 0.95 between two independent variables.
Would it be omitting a variable, the important variable?
Yeah, Sean, exactly. The omitting of an important variable is going to cause the thing to be biased. Do you guys remember? The next question is very important. So it delves right into what I was just going to start babbling on about. Number 8, suppose average worker productivity at a manufacturing firm's average productivity depends on two factors: average hours of training and average worker ability. So average productivity is equal to beta sub 0 plus beta sub 1 times average training plus beta sub 2 times average ability plus an error. Assume this equation satisfies Gauss-Markov. That means the 5 assumptions that we listed in the chapter. If grants have been given to firms whose workers have less than average ability, so the average training and average ability are negatively correlated, what is the likely bias in tilde beta sub 1 obtained from the simple regression of average production on average training? So let's look at this slower. Grants have been given to firms whose workers have less than average ability. Therefore, average training and average ability are negatively correlated. Yeah? So average ability and average training are negatively correlated. Hence, they're getting money. The likely bias in tilde sub b, tilde beta sub 1. So that's a regression eliminating this average ability. Yeah? Now, average training is clearly important. How do we answer this question?
Would the bias be that since these firms know that they're giving grants if they have less than average ability, would they want to keep that less than average ability in order for them to get more grants because they know it's continuing them for them?
All right. All right, Joe. Thank you. I'm gonna, in the interest of time, table 3.2, summary of bias in beta tilde sub 1 when x2 is omitted, estimating equation. Okay? So we're going to omit it, right? And you've got table 3.2 in your textbook. We're omitting X2, which is average training, right? So the first thing is the correlation positive or negative?
Is it negative?
It's negative. They tell us it's negative, don't they? Right?
Yeah.
Besides, we know that the people who are doing lousy are getting more training. That in effect is saying it's a negative correlation. Yeah. What is the sign on average training? Intuitively, what's the sign? When you get training and you get better, right? Yeah. So you get better, that means that the sign on average training has to be positive. Yeah. So we know that they're negatively correlated and beta sub 2 is positive. Yeah. Therefore, there is a negative bias according to the chart. All you got to do is look it up on the chart. Right? that chart. Can you guys see that?
Yeah.
Okay, that's a very important question. You will likely see it again. Okay. That was it for the standard questions. That was it for these questions. What was left were these questions. Computer question 1 and computer question 2. So we want to work on these. I'm going to take the rest of the class to do this. So get these questions out in front of you. Get the questions out in front of you because I want to share. Oh, shoot. I want to share my R for you. Did people work on these?
Yeah.
And how did it work out? Zaya?
I tried them, but I couldn't really figure it out.
Dejor?
I really don't have nothing for the question.
What?
I don't know.
Drake?
Um, nah, I didn't get them.
Paige?
I don't really know.
Charlie?
No, I didn't get them.
Caleb?
No, I didn't get them.
Elias?
I wasn't able to get these ones.
Brooke?
No, I wasn't able to.
All right. Let's rephrase the question. How many tried to get it? Zoya, you tried? For how long?
I tried not that long. It was probably like 20 minutes. I got some of the answers to the first question, but then like when I started to try to actually like run the regression, it wasn't working.
No, you were getting an error.
Yeah.
So all that red in R, right?
Yep.
What were some of your other experiences?
I also got a bunch of red things when I started to do the regression because I think you basically had to start off the problem with the regression and I couldn't get it because I had to assign the variables, I think, of like X and Y, and I didn't know how to do that to get the regression.
Somebody else?
I was able to get it working from what you showed us yesterday in class, or I mean on Tuesday.
Oh yeah, and you got answers?
Yeah, I got the first two.
Oh, the first two for computer problem 1.
No, computer problem 1, computer problem 2.
Oh, that's all we had to do. All right. So now you guys know to go to Matt. He's the man. Yeah? He's gonna make a lot of money teaching you all how to do this. All right. So let me ask you this. If I walk through the problems in my R showing you what to do, is that helpful? Yeah?
Yes.
Okay. So we start with R. So computer problem, question number 1. Says a problem of interest to health officials is to determine the effects of smoking during pregnancy on infant health. One measure of infant health is birth weight. A birth weight that is too low can put an infant at risk for contracting various illnesses. Factors other than cigarette smoking that affect birth weight are likely to be correlated with smoking. We should take those factors into account. For example, higher income generally results in access to better prenatal care as well as better nutrition for the mother. An equation that recognizes this is birth weight is equal to beta sub 0 plus beta sub 1 cigarettes plus beta sub 2 family income. What is the most likely sign for beta sub 2? Anybody?
Positive.
Positive.
Well,
Positive.
how come?
More income, more parental care, so the baby's weight will be more.
Exactly, right? So more family income, we would imagine the birth weight to be higher, right? The kid's not starving. What about, what do you think? Do you think cigarettes and family income are likely to be correlated? You guys have the problem in front of you, right?
I would say yes, because lower income families normally more likely to smoke.
Okay, so you think they're negatively correlated?
Yes.
All right, that makes sense. Cigarettes are expensive, though.
True.
Now they're real expensive. Anybody else?
Well, they're expensive. They're a staple. People are willing to pay for them despite the price point.
So you think they might be positively correlated?
No, I think they're negative. Jesse said they're positive though in the chat.
Oh, what's the chat? I didn't see any chat. Oh, one. Having a lot of money is stressful, leads to smoking. Yeah. All right. Yeah, I guess that could be true. You know, well, it's hard to know what the answer is to this. Nor it's hard to know whether you know, if you make a lot of money, chances are you're smart. So chances are that if you're particularly well educated, you've decided not to smoke. Yeah. So it's hard to say. Let's have a look at the R problem. So, do you think SIGs are likely to be correlated? Find the correlation. Why might the correlation be positive or negative? And then part 3 says, estimate the equation with and without family income using the data in B weight. Report the results in equation form, including sample size and R squared. Discuss the results focusing on whether adding family income. Oh, everybody send me a chat saying you're here. Okay, good. Thank you. Now, I want to open up a file, an old one. Scripts. And copy these first 5 lines. It's what I always do. Now I start a new script. So what did I say here? I commented, list all the objects currently in the workplace. The command is ls parentheses. There's nothing, 0. Remove all the variables from the workplace. This is rm list equals ls parentheses. I just do this as a matter of course. Clear the console screen. That's cat parentheses quotes /f. All that is the language. If you hit control, I think it's control L down here. Control L clears your screen. The command, when you hit control L on your computer keyboard, the command that the language in the computer is cat /f. That's what that is. Okay. That's the code to make control L happen. Find your directory that you're in, right? Get working directory. So I'm in this directory already, but if I was not, I want to set it to this. Yeah. So that's where I keep my R data, right? Users, M. Gallagher, documents, econometrics, R data. Now, what do I need? I need to load this data. What is it? B weight, right? So I'm going to comment it in. And then I got to write the code. I want to load parentheses, quotes, birth weight dot R data. Let's run that. It worked. Let's have a look at that data. Well, I just clicked on it over here on the environment window, and it opens up. It's like a giant spreadsheet. Family income, cigarette tax, cigarette price, B weight, father education, mother education, cigarettes, etc. Right? So we see the data, you know what we're talking about. Now, I'm going to clear this with Control L, and I'm going to get rid of this. Yeah, get rid of that. So I just did this because I just want to show you. I'm going to go over here to environment on the right and say open. And now this could be, anywhere in my computer, but I know documents, econometrics, our data.
My R session keeps booking.
And B-Wave. So it loaded it again by doing it this way. So you can do it by point and click, or you can do it through the code. Yeah. If you took this code, copy that code, right? And then I'm going to say Control L. I'm going to say sweep this clean. I'm going to come over here, put a few lines of empty, and I'll paste this, load, right? And then I'll say, run that little line of code. And it did it again. Just notice that it says load, and the command for including all the stuff ahead of what this is a tilde. So they just use tilde. You could do that too. I prefer to say, this is exactly where my file is. It's just, I guess, what's the word I'm looking for is, I'm anal. That's what it is. More anal about it, Okay, so we're all done here. We got this. Control L. You know what? I'm going to run this whole bit of code again just to be on the safe side. Okay, and we're all back to here. So we loaded the data. Now, estimate the equation with and without family income using data in birth weight. Report the results in equation form. So what do I need to do now? You know what? I'm going to look at this data again because we need what? SIGs and family income, right? What are those columns? They're SIGs, so it is just CIGS and family income. Oh, it's over here. Fam income. So you know what I'm going to do? I'm going to get rid of that. I'm going to say, let X1 be assigned the value of open parentheses data, because that's the name of my data set, $, because I want just one column, and I want SIGs. Yeah? So, but I got to comment this in somehow. Let's, what are we going to say? We're going to say, comment, create X1 variable SIGs. Yeah? Okay, so run that piece of code. And then look, it generated it over here, right? Then we gotta have X2. In the equation, X1 is definitely SIGs and X2 is family income. So say X2, assign the value, open parentheses, data, $, fam income. Oh, but I want to comment that so I know, if anybody goes to look at this, I'm going to say hashtag create X2 variable family income. Okay, so now run that code, run. Okay, that generated this over here, the stuff that I'm creating. Yeah, so we created the two things. Oh, we're regressing birth weight on these things, aren't we? So we need another variable. I'll comment it in. Create dependent variable y birth weight. Yeah? Yeah. Oh, this should be an E here. Hang on. Okay. Create dependent variable birth rate. Okay, so y assigned the value open data $BWGHT. Yeah, and run that. Okay, so we got X2, X1, and Y, right? So now we can, we could run a regression, but you know what? Didn't it also ask us what was the correlation between X1 and X2, income and cigarettes? Let's find that out. Comment. So I just say core open X1, comma, X2. That'll tell me run. Oh, look, it's negative 0.17. That's very small, right? The correlation is very small. I mean, just for, we just did that, for shits and giggles, So the correlation is very small and it's negative, yeah, which is what I think some of you guys have said. Now, it asked us to do the regression. So let's call it regression of both. We're using both variables now. The code for regression, linear model, open parentheses, y, the dependent variable, tilde, x1, comma, no, plus x2. Yeah? Let's comment in. Regression with both variables. Run that. So, summary. Of reg both. Look at that. So the regression including X1 and X2, we have an intercept of 116.97. We have a slope of negative 0.46 on the X1, which is cigarettes, and a very small slope, 0.0927 on family income, right? So the R squared of this thing is 0.029. So now let's run this regression without family income and see how it changes. Regress maybe without fam income. Let's comment this in. Without family income. Okay, I want more space. So we have regress without family income, assign the value, linear model, parentheses, y, our dependent variable, tilde, only x1. Yeah, that's all. And then summary. What's it called? Regress without fam inc. Run that. Okay. So what happened here? Without family income, we got an R squared of 0.0227 versus 0.029, right? So the R squared is a little smaller. When we add family income here, let's open this up so we can see them both at the same time. Right, so we have this one is with both and this one is without. So when we add family income, that's down here, the effect of cigarette smoking is slightly smaller. Intercept of 0.119. Oh, this is without. This is with. So what we're talking about is the effect of X1. This is a negative effect, as you would expect. If you're smoking cigarettes, it's negatively affecting your birth weight. If you have family income and you add that to the equation, the effect here on birth weight is slightly less than it is if you leave this out. Right? We left it out over here, and the negative effect is greater than it is here. Does that make sense? But it's not very much. It's really small. The difference is like 0.46 to 0.513. That's really small. So on $1,000, on $10,000 in income, that's like a difference in 0.9 ounces in a baby. So Discuss your results, focusing on whether adding family income substantially changes the effect of cigarettes on birth rate. It's not very big. The change is not very big. Adding that to your equation doesn't help explain it very well, right? That was minuscule. Okay, is this helpful? You guys know what I'm doing?
Yeah,
Let's do
it's
the
way
next
more helpful having you like do it with us.
Is it? Let's do the next one. So here's what I'm going to do now. I'm going to say, I don't want this anywhere, but I want these first few lines, yeah? We always start all our code with the same. Copy that, and then I'm going to get rid of this. Well, for you guys should save it, right? I've already saved it, but save it to your our data, our scripts. Save it as chapter 3, computer problem 1, yeah, 2020. Okay, and then you say save. So I'm going to get rid of that because I don't want to save it. You guys should save it. Control L clears that up. Get rid of this. Clean that all up. You start with a new thing. Open a new script. Yeah. Start with those copied lines that I always do. Just run that to get yourself started. Yeah. Okay. Now, what does problem 2 say? Problem 2 wants us to use the data in H price 1 to estimate the model. Price is equal to beta sub 0 plus beta sub 1 square feet of a house plus beta sub 2 number of bedrooms of a house, where price is the house price measured in thousands. Write out the results in an equation form, in other words, in this form. What is the estimated increase in price for a house with 1 more bedroom? Estimated increase in price for a house with an additional bedroom is 140 feet in size. Compare the answer. So we've got to get this data and we've got to run this regression. So let's go and get the data we want. Load the data you want. So this is load, parentheses, quotes, H price 1 dot R data. I think that's what it's called. Run. All right, it gave it to me. Now again, I'm going to get rid of this. Yes. Yeah. And I'm going to load the data through this little thing over here. Just open a folder, a data set folder. And this is, I'm in our data. So it was H price, right? We can go over here. It's alphabetical. Thank God for that. H price, same stuff. 88 observations. Let's have a look at it so we know what we're dealing with. So we have the price, the assessed value, the number of bedrooms, how big the lot is, the square foot size of the house, a dummy variable colonial, right? If it is or if it isn't. L price, L assessment. This must be logs. Log of lot size and log of square feet. Okay, anyway, we just know now that, so we have square feet is SQRFT and bedrooms is BDRMS. Okay, so let's get rid of that. And the regression wants us to regress the price on square feet and bedrooms. Yeah, that's what the question is asking. So we need a dependent variable Y. So comment it in. Create Y dependent variable. And that's going to be, so Y, assign the value, open, data, dollar, price. Yeah, and then run that. Okay, it worked, right? Many times it's gonna not work and throw up all that red stuff. So then we got to create the X1. Create X1. Can't seem to spell very well. X1 till parentheses, it's in data. Just call me sausage fingers. Data. Square foot, right? SQRFT. I think that's what it was. Run. That seemed to work. And what do we need now? Create X2. So X2 was assign the value, open, data, dollar, what was it? Bedrooms, right? BDRMS. Okay. Run that. Okay, I think we got everything in there, yeah? So now what do? Regress. You call that anything, man. Call it Pooh Bear, you know? But I like to call it regress. And we'll say a linear model of Y tilde X1 plus X2. Oh, okay, I called it FEG. Regress. Run that. Okay, we got our regression. Summary, reg. Run that. What do we get? Ah, there we go. Look, it worked. How about that? So let's go down here and make this a little bit, okay, so everybody can see, because we got to analyze it now, don't we? So the intercept, the 19, so this is beta sub 0 is the intercept, negative 19.315. Our beta sub 1, X sub 1 here is 0.12844. And the intercept, the slope on X2 is 15.198, okay? R squared 0.63, that's pretty good. We have, how many data points were there? Look at over here, 88 observation, right? This says 85 degrees of freedom. That's because we're estimating 3 things, yeah? So, and description, 10 observations of 2 variables. All right, whatever. So the question say, write out the results. So you could write that equation, yeah? Just like I just said. What is the estimated increase in price for a house with 1 more bedroom? I'm just checking in them to see what you're all doing, you know. Make sure everybody's, what do you think? What is the estimated change in price for 1 more bedroom?
Is it $15,200?
$15,200. That's exactly right. That's the coefficient we estimated on X2, which is number of bedrooms. So increase number of bedrooms by 1, and house price goes up by 15.2, and it's in thousands, isn't it? Come back, come back. It's right here. The coefficient on X2, and we defined X2 as number of bedrooms right here. So 1 additional bedroom implies that the price of the house is 15.198 times 1,000, because it's in thousands. So $15,200 more. Excellent. Thank you, Matt. What is the estimated increase in price for a house with 1 more bedroom that is also 140 square feet in size? And compare that to the answer. You're looking at, sorry. You're looking at this, right? The equation is the price, beta sub 0, beta sub 1 times square feet plus beta sub 2 times bedrooms. So we just said that the coefficient on bedrooms is 15.198. The coefficient on square feet is 0.128. So if square feet goes up, square feet here goes up 140, it's 140 times 0.128, increase in the price, plus 15.198 times 1. So the total change in price associated with an additional bedroom and an additional 140 feet of square feet is $33,120. Here's a good question that we expect you to be able to answer. What percentage of the variation in price is explained by square footage and number of bedrooms?
Would that be the R squared?
Yes. Who said that?
Me.
Exactly. So how much?
0.6319.
So
So 600.
No. That's a percentage. So it's 63%.
Oh, okay.
63% here. Yeah, R squared is a percentage. It's the percentage of variation in Y explained by X. That's your R squared. So the percentage of change in price of the house explained by square footage and number of bedrooms is 63%.
What's the adjusted R square for?
So the adjusted R squared, and I think did we talk about that or we didn't talk about that? Adjusted R squared is, and I have to remember, that's a great question and I'll answer it. I just need to refresh my memory. So I'm going to look. This will come up when we start talking about adding variables to models. So adjusted R squared imposes a penalty on R squared for adding additional explanatory variables. Remember when we said if you add an explanatory variable to a regression, your R squared is going to get better, right? I mean, you're just using more and more stuff to explain the variation in Y as a result of X1, X2, X3, X4, right? If you have a lot of explanatory variables, R squared gets better. Adjusted R squared imposes a penalty, and it's a trade-off between the better fit in terms of standard errors and the better R squared. So, and it comes up in chapter 6. So it's a measure of saying, compared to the fit, you're not improving your model with adjusted R squared. Does that make sense? It's a number that allows you to weigh the difference between adding an explanatory variable or not. Yeah, because your R squared would go up, but how much of a variance does it add? Does that make sense?
Yep. But do we need to use it for something, or is it just?
You will when we get to building models and deciding, should we add this or not?
Okay.
Right? If you guys are going to do a project on baseball salaries of major league players, and you build a model with RBIs and home runs and errors, and you add all this crap into your model, right? The adjusted R squared is one way to say, well, we shouldn't add that. It's improving the fit, but it's making the variance much higher. You see what I'm saying? So yes, we'll get to it when we start building bigger models. Okay. Did I answer your question?
Yeah, but
What's the next question here? And let's wrap this up. So the first house has square feet of 2,438 and bedrooms equals 4. What's the predicted selling price from this house with our OLS regression? Look at the data. The first house has square feet of 2,438 and 4 bedrooms. Yeah, you can see that here. 2,438 and 4 bedrooms. What's the predicted selling price? Well, you got to put it into this equation, yeah? This is your intercept, right? We have price is equal to negative 19.31 plus 0.128 times 2,438 square feet plus 15.198 times number of bedrooms and get an answer. Yeah? The answer, if you put it all, plug it all in, is $353,000. So the question then asks, and I don't have it in front of me. The question asks, what does the data say the actual selling price of the house? It's right here in our data set. 300,000. So we just ran a regression that estimated the value of this house at 353, didn't we? Right? Didn't we? We just ran that regression. If you plug in the numbers, you find the house price of that house should be 353. But that dude bought the house for 300. That suggests that the dude got a bargain, right? Doesn't it? What do you think? The dude paid 300. Our regression says he should have paid 353. What's wrong?
Well, there's more things than just like the square footage and bedrooms that affect how much a house should sell for.
And exactly. Thank you, Sean. Exactly. There's all kinds of shit that goes into how much a house price should be, right? We're talking about, we did this little rinky-dink model just to try to illustrate what does it mean when we generate these coefficients and how do we interpret them? That's what we're after here. Remember at the beginning of the course, I said, I'm far more interested that you understand the intuition behind what we're trying to do. So it could mean that the dude got the house at a bargain. Yeah, he paid $300,000 for a $350,000 house. But it could also mean that we should be adding a lot more variables to the equation, like how much acreage was there? You know, how close is he to the bar? How close is he to the town dump? You know what I'm saying? There's all kinds of other things that may affect the price of the house that we haven't accounted for. But what we're after here is for you guys to have an understanding of what we're interpreting and how to build the model and how to use R to make it happen. If you can use R, you can use Python, you can use all these other things. Okay? All right, so that's it for today. When we come back next week, we're done talking about R for the time being, and we're going to launch into chapter 4 in the textbook and move on with that stuff. Back to like lecture and stuff like that, right? So please play with R and see if you get, can get it to run and get the answers that we've got. I put this stuff up on Moodle. And if anybody's having trouble, let me know and I'll help you out. All right? All right, everybody, be safe. Have a good weekend.
Thank you, Professor.
Thank you too.
Thank you.
Thank you, Professor Gallagher.
You're welcome.